Hello learners, before we get into our topic today, I want to give a brief overview about what we will be covering in today's session. We will be exploring about the different types of bonds in brick wall. We will discuss the key points of brick bonding, the importance of brick bonding, rules for effective bonding and the different types of brick bonds. A overview of brick bonding. Brick bonding is the systematic arrangement of bricks in a structure to ensure strength, stability and aesthetic appeal. The pattern of brick bonding is critical in distributing the loads uniformly across whole of the wall, avoiding any continuous vertical joints that could compromise with the structural integrity of the masonry. Various bonding patterns are used depending upon the requirements. The requirements can be architectural, it can be the structural load, how it is to be distributed and the desired visual effect. The functions and structural importance, the very first point. Under this, as far as the importance is concerned, the very first thing is load distribution. The primary function of brick bonding is to distribute the loads imposed on the wall evenly across the structure. By staggering the vertical joints, the brick bonding prevents the formation of weak lines that otherwise could lead to cracking or failure. So, the primary importance is that we have to avoid the vertical joints. This is particularly important in the case of the load bearing walls, where the weight of the structure its above must be supported without compromising any kind of stability. The structural integrity. The second point, proper brick bonding enhances the overall structural integrity of the wall. By interlocking the bricks in a systematic pattern, the masonry resists the shear forces and lateral loads such as wind pressure or even seismic activity. So, interlocking is very important. This interlocking mechanism also improves the wall's resistance to bending and thereby increasing its durability and lifespan. Next point is about the aesthetic considerations. Initially we have discussed about the structural part, now the aesthetic considerations. Beyond the structural considerations, the brick bonding contributes to the aesthetic quality of a building. Different bonding patterns are there. So, depending upon the pattern that is being followed at a particular wall, this pattern can create varying visual effects, from the uniform appearance that occurs for a Flemish bond to the more dynamic look of a herringbone bond. So, the choice of bond often reflects the architectural style and the design intent of the structure. Next is about the rules of effective bonding. In order to ensure a strong bond in masonry, some rules are to be adhered to. Number one is about the uniform brick size. We have the different types and the kinds of bricks. So, the bricks that we are going to use should be of uniform size. The length of a brick should be twice its width plus one joint. This will ensure a uniform lap. So, and if the laps are non-uniform, then it may compromise with the strength of the bond. Second is minimum lap. The minimum overlap should be 1/4 of a brick along the wall's length and 1/2 of a brick across its thickness. So, the requirement for the lengthwise and the crosswise directions are different. Next point is the use of brick beds. The use of brick beds are nothing but the broken pieces of bricks. So, these brick beds should be minimized except in special circumstances. So, as far as possible we should use the complete bricks, and only under special circumstances we can use the broken pieces. Next point is the header and stretcher alignment. In alternate courses, we have the different courses, that is the layers. In alternate courses, the center line of a header should align with the center line of the stretcher in the course immediately below or above it. Next point is about the vertical joint alignment. The vertical joints in alternate courses should be aligned along the same perpendicular or perpend we call. So, in the alternate courses we can align the vertical joints. So, one joint, in the second one there should not be continuity, and in the third one again in continuation. Next point is the use of stretchers and headers. Stretchers should only be used in the facing of the wall, while hearting, that is the interior of the wall, should be constructed using headers only. So, this is the use of the headers and stretcher. Next is the header courses. Ideally speaking, every 6th course should be a header course on both the sides of the wall to ensure structural stability. Now, we come to the different types of brick bonds. The various types of brick bonds are used in masonry work, each with its unique characteristics and the application. So, based on the characteristic and the application, we select the particular type of the brick bond. Number 1 is the stretcher bond, number 2 the header bond, 3 English bond, next Flemish bond, 5th facing bond, 6th English cross bond, 7th is brick on edge bond, 8th is the Dutch bond, 9th raking bond, and 10th zigzag bond, and 11th is the garden wall bond. Let us take one by one. Number 1, the stretcher bond. A stretcher bond is a brick laying pattern which is characterized by the horizontal placement of bricks such that only their long faces, the long face is called as the stretcher. So, the stretchers are visible in the facade. The bricks are laid in a way that aligns their length parallel to the direction of the wall. It is necessary to ensure the uniformity and continuity in the appearance of the wall surface. So, this is something important, that the course laying should be such that the uniformity and the continuity in the appearance is maintained. This stretcher bond is mostly employed in walls with a thickness equivalent to half a brick. Half a brick means approximately 90 mm, or in inches we take it as the 3.5 inches. Such walls are often non-load bearing and serve the specific purposes including partition walls. So, they are non-load bearing walls. So, non-load bearing, the most common partition wall. The internal walls that divide the total space within a building without bearing the structural load of floors or the roofs. So, that is the kind of wall, partition walls. Second comes sleeper walls, low height walls, that is designed to support the joists of ground floors in buildings, very often found in structures with suspended wooden floors. So, there we go for sleeper walls. Next one is division walls. Similar to the partition wall that we discussed as the very first type, but may be used in the outdoor settings or as garden walls to demarcate the areas. Next, chimney stacks. Vertical structures that extend beyond the roof line of a building, designated to safely vent smoke and gases from the fireplaces, stoves or boilers. So, that comes under the chimney stacks. Purpose is for the safe exit of the smoke and gases. Now, we come to the technical considerations. As discussed, number 1 is the load distribution. The structure bond is primarily aesthetic and lacks the interlocking of bricks as otherwise seen other bonds like English bond or Flemish bond. Now, this limitation of the structure bond makes it unsuitable for walls which require substantial load bearing capacity or shear resistance. So, there this cannot be used. Next one is wall thickness. As a structure bond is only half a brick thick, it does not provide the structural integrity which is needed for external or load bearing walls. So, where the thicker bonds are preferred, as you understand that for the external or load bearing wall we need a thicker section. So, here these where the thicker bonds are preferred to ensure stability and strength. Next is the structural stability. For thicker walls, the structure bond fails to offer adequate tie between the brick courses, which could lead to instability when the load is applied. So, in those cases, alternative bonding patterns which incorporate the headers means the brick laid with their short face showing, are recommended to enhance the wall's mechanical interlock and strength. Next is header bond. The header bond, also known as the heading bond, is a traditional brick laying pattern where all the bricks are laid as headers, meaning their shortest face mean width. So, the width is exposed along the wall's length. This orientation is in contrast to what the stretcher bond is. So, where longer faces are aligned along the wall. So, here the shorter face and there it is the longer face which is aligned along the wall. Now, comes the application, the header bond. The header bond is particularly well suited for walls that are 1 brick thick, that is directly the thickness of the brick is going to serve the purpose. So, 1 brick thick, the thickness approximately is 180 mm, or in inches it is around 7 inches. This is often employed in specific types of construction, where the structural and aesthetic demands both align with its characteristics, including number 1, the curved brickwork. Now, wherever the curved brickwork is to be provided, the header bond is advantageous in such locations, because it avoids the need for extensive cutting of the stretchers. This will otherwise provide a protruding portion beyond the wall's curvature. So, this one results in a smoother, more uniform finish in case of the curved walls. Footings. This bond is also used in the construction of footings. Footings mean the base of a wall or a column that distributes the load to the ground. Now, if we go into the construction details, in the header bond, the overlap between the bricks in successive courses is typically half the brick's width. Half the brick width, that means again around 4.5 centimeter, and in inches 1.75 inches. This overlap is achieved by incorporating 3/4 brick bats. So, the brick bat means the bricks that are cut to 3/4 or 3/4 of their length. So, that is the 3/4 brick bat. This is used as quoins or the corner bricks in alternate courses. This method ensures the stability and continuity of the bond throughout the wall, especially at the corners and edges. Now, we come to the technical considerations. As far as the technical considerations are concerned, the number 1 is the structural strength. While the header bond offers some resistance to vertical loads, it lacks the ability to efficiently transmit horizontal pressure along the length of the wall. Now, this becomes a limitation. This limitation reduces its suitability for load bearing applications, where more robust bonds like the English bond or Flemish bond are preferred. Limitations: the header bond does not provide sufficient mechanical interlock or tie, that is the gripping between the bricks to ensure the unnecessary structural stability for load bearing walls. As a result, its use is generally confined to non load bearing walls or specific architectural features where its aesthetic and the construction benefits, it has aesthetic benefits. So, in those locations where it outweighs the structural limitations, it can be used. Next, that is the third variety is English bond. The English bond is one of the most traditional and structurally sound bricklaying pattern. This is widely regarded for its strength and durability. So, both the aspects, that is the strength and durability, are available in this type. This bond is composed of alternating courses of headers, that is the bricks which are laid with their shortest face or width showing, and the stretchers, that is the bricks laid with their longest face or length showing. The alternating arrangements of these two brick orientations give the English bond its characteristic appearance and contributes to its structural robustness. The construction features of this: number 1, the course arrangement. The English bond's hallmark is the alternating pattern of header and stretcher courses. In the elevation view, that is from the front, when we see one course displays only the headers, while the next course will display only the stretchers. The vertical joints in the header courses align vertically across courses, as do the vertical joints in the stretcher courses. So, this alignment ensures that the load is evenly distributed across the wall, contributing to bond's high structural integrity. Second point is joints and lap. To prevent continuous vertical joints, we know that if the continuous vertical joint is there, that is the point of weakness. So, to prevent this that weakens the wall, the queen closures we just discussed, that is the brick pieces that are 3/4, that is the 3/4 the length of a full brick. So, these are strategically placed next to the first header in each header course. This placement ensures that the joints do not align vertically over successive courses and reducing the potential for cracks. In stretcher courses, each stretcher course overlaps the header below it by at least 1/4, that is the 1/4 of its length, which is approximately 2 to 3 inches or 50 to 75 mm. It further enhancing the wall's stability by creating an interlocking pattern. Another one, wall appearance. For walls that are even multiple of a half a brick in thickness, for example, 1 brick thick or 2 brick thick walls, both the faces of the wall exhibit the same pattern of alternating headers and stretchers. In contrast, for walls with an odd multiple of half brick thickness, for example, 1.5 brick thick or 2.5 brick thick wall, one face of the wall will display the headers, while the opposite face will show the stretchers. Now, this results from the need to maintain the structural pattern across the varying wall thicknesses. Next is the hearting. In thicker walls, that is the walls thicker than the one brick, the middle portion, which is known as hearting, is typically filled with headers. This filling ensures that the wall's internal core is a solid and stable as the outer faces, reducing the likelihood of internal weaknesses that could lead to structural failure. Next is the transverse joints. Transverse joints are joints that run perpendicular to the wall length in an English bond. It is crucial that at least every alternate transverse joint extends continuously from one face of the wall to the other. This continuity ensures that the wall behaves as a single cohesive unit under load rather than a series of discontinuous layers. Next one is the header course. The header courses should not begin with queen closure. Instead, these should be placed immediately after the queen headers, that is the first header at the corner of the wall. This arrangement prevents the weak points that could result from starting a course with a queen closure, which might otherwise disrupt the bond's structural continuity. In stretcher courses, queen closures are not used as their inclusion is unnecessary given the orientation of the bricks. Next is the joint thickness. The thickness of the vertical joints in header courses is generally less than in stretcher courses. This difference arises because the header courses contain twice the number of vertical joints as compared to stretcher courses. Thinner joints in the header course help to maintain the structural integrity of the wall, preventing the excessive use of mortar, which could otherwise lead to weaker joints. Next type of bond is the Flemish bond. Flemish bond is a sophisticated and aesthetically appealing bricklaying pattern, where each course in the wall consists of alternate headers, that is the short face, and the stretcher, that is the long face of the brick. This bond creates a visually distinct checkboard pattern on the wall surface, contributing both its structural integrity and its decorative appeal. The Flemish bond is often employed in both load bearing and non load bearing walls, where appearance is as important as function. The construction features, that is number 1, course composition. In Flemish bond, each course alternate between headers and stretchers. That means that a header is followed by a stretcher, with this pattern repeating across the entire course. The alignment is such that in one course the headers are positioned centrally over the stretchers of the course below. This arrangement provides a good distribution of the wall's load and help to avoid vertical joints that run continuously through multiple courses, which could compromise the wall's stability. Next, the queen header and queen closer. In every alternate course, the course begins with a queen header and the corners. The queen header is a standard brick laid at the corner to maintain the alternating pattern. Adjacent to this queen header, the queen closers are placed. The queen closers are bricks that cut to 3/4 or half of a full brick length. They are used to maintain the proper spacing and ensures that the bond pattern remains consistent across the wall face. This strategic placement of queen headers and queen closers is essential for establishing a proper face slab, ensuring that each header in the bond is appropriately supported by the structure below it, thereby enhancing the wall's structural stability. Now, next is the face slab. The face slab refers to the overall overlap of the bricks in successive courses, ensuring that the vertical joints do not align directly over one another. In a Flemish bond, this overlap is carefully controlled by the use of queen headers and closers, allowing for a visually consistent and structurally sound wall. The alternating arrangements ensure that every header is supported by the structure below it. Now, this reduces the likelihood of cracks developing in the wall. The Flemish bonds are characterized into two types. Number one, double and single Flemish bond. The first one, the double Flemish bond. In a double Flemish bond, each course has alternating headers and structures, presenting ideal appearances on both front and back faces. The queen closers are used next to queen headers in alternate courses. The walls with odd half brick multiples use half and 3/4 bats, while even multiples do not require bats. Single Flemish bond, uniform Flemish bond, English back, front follows the Flemish pattern and back may vary. Similar queen closers, less structured but bat are used, balances the strength and aesthetics, simplifying the interior construction. The double Flemish bond offers better visual symmetry on both faces of the wall, while a single Flemish bond provides the aesthetic on the exterior only, often simplifying the construction and potentially reducing the cost. So, dear students, in previous slides you have learnt about the main type of the bonds, mostly the English bond and Flemish bond. We are now in a state to compare both of the bonds. Number one, English bond is a stronger wall for over 1.5 bricks thick, whereas the Flemish bond offers a more pleasing appearance. The Flemish bond uses broken bricks, which is called as the bats, and therefore, they require more mortar because more number of joints will be there. So, more amount of mortar will be needed. The Flemish bond construction demands greater skill than the English bond. Facing bond. Facing bond, it is the weakest brick bond, which is characterized by the use of bricks with varying thickness for the walls facing and backing. The headers are inserted only after several structure courses have been laid, with their spacing determined by the least common multiple of the brick thickness. This irregular spacing and the infrequent use of headers results in uneven load distribution, making the bond structurally unstable. The facing bond is typically used for aesthetic purposes where the exterior appearance is prioritized over the structural integrity, making it unsuitable for load bearing walls or the applications where the strength is crucial. English cross bond, it is a refined variation of the traditional English bond designed to enhance both the strength and aesthetic appeal of the brick masonry. The alternating courses, the bond features alternating courses of headers and stretchers similar to the traditional English bond. This arrangement provides a strong structural base and ensures effective load distribution across the wall. Queen closures placement. To prevent the continuous vertical joints, the queen closures are strategically placed next to the queen headers. This ensures a strong interlock between the courses, enhancing the overall stability of the wall. Next is the header introduction in stretcher courses. In alternate stretcher courses, headers are introduced next to the queen stretchers. This modification not only strengthens the bond, but also adds a distinctive visual pattern, making the English cross bond both robust as well as aesthetically pleasing. So, the combination of these features makes the English cross bond an excellent choice for walls where both structural integrity and visual appeal are important. Dutch bond. Dutch bond is masonry pattern that alternate headers and stretchers similar to the English bond, but includes a 3/4 brick bat at the start of the each stretcher course. This configuration enhances the corner stability and structural integrity, making it ideal for load bearing walls. Now, the design not only reinforces the wall's strength, but also offers a visual appealing facade, making Dutch bond a preferred choice in construction. Next is the raking bond. Raking bond is a masonry technique used to enhance the stability of thick walls by positioning the bricks at an incline relative to the wall's direction. This angled arrangement provides additional longitudinal strength and is typically applied at regular intervals, alternating and the inclination in successive courses. Now, the raking bond is particularly effective in reinforcing walls constructed with English bond, improving the overall structural integrity while maintaining a staggered appearance. The raking bonds are primarily of two types, the diagonal bond and herringbone bond. The diagonal bond is method where bricks are laid at a consistent 45-degree angle to the horizontal plane. This is particularly effective in walls that are between 2 or 4 bricks in thickness. The diagonal arrangement of bricks ensures that the corner of each brick align precisely with the external edges of the stretcher laid in adjacent courses. This alignment not only reinforces the bond between the bricks, but also enhances the wall's ability to resist the lateral forces, making it suitable for structural applications where stability is critical. The diagonal bond is often utilized in the scenarios where the wall thickness requires additional reinforcement without compromising on the linear continuity of the structure. This bond is especially useful in situations where walls are subjected to uneven loading or where additional shear strength is required. The herringbone bond is a more decorative form of raking bond characterized by bricks laid at 45-degree angle, but in alternating opposite directions. This zigzag pattern creates a visually striking effect often used in decorative finishes for walls which are thicker than 4 bricks. The alternating direction of the bricks in herringbone bond enhances the aesthetic appeal of the wall while providing a unique method of load distribution. Unlike the diagonal bond which is primarily used for the structural reinforcement, the herringbone bond is favored for its decorative qualities. So, today we have learnt about the bricks, the brick masonry and the different types of bonds in walls, their use and the conditions about the particular type of bond where it can be used. Thank you.